All right, 3.5, graphing linear equations in slope-intercept form. All right, a lot of graphing in this particular lesson. Describe the slope of each line, then find the slope. Okay, what's happening with this line? We'll just describe what's taking place going from left to right. Oops. Well, it's going upward from left to right. So just state that. The line rises from left to right. All right, that's all you have to say. And now find the slope. Okay, so what's happening here? All right, well, they already give you the graph, and they point out what the rise is and what the run is. Okay, so slope is simply rise over run. And you don't really have to do any math just by looking at what they give you in this grid here. They tell you what the rise is. The rise is 4. And the run is 6. Okay, and you could simplify that. Divide both by 2, and you get 2 over 3. So that's my slope in this problem. All right, for the next one, describe the slope. What's happening going from left to right? It's falling. Okay. So we say the line falls from left to right. All right, now for the slope, no calculations necessary. They give you the information in the problem itself. All right, so it goes right 2 and it falls 3. All right, whenever it goes down or to the left, that's a negative movement. So my slope here is rise, which is -3. Okay, when you're going down, it's negative. Same thing with going left. So down 3, and then to the right 2, that's positive. All right, so typically when you state your final answer, it's -3 over 2 with a negative next to the division symbol. All right, that's all there is to that example. On to the next. The points represented by each table lie on a line. How can you find the slope of each line from the table? What is the slope of each line? Okay, how can you find the slope of each line from the table? Well, since they give you a table, you simply have to choose any 2 points. So that answers the first question. Choose any 2 points. What is the slope of each line? Okay, well, let's see. For part A, I'm just going to choose the first 2 points. All right, here is my slope formula. y1 minus y2 over x1 minus x2. All right, and for my first point, x1, y1, and then I have x2, y2. All right, this is my x1, y1 here. This is my x2, y2 here. So I have 420, and then I have 714. So I end up with 20 minus 14 over 4 minus 7. So I get 6 over -3, which is -2. That's my slope for part A. Then for part B, same deal. Just going to choose the first 2 points. Oops, that's 1. All right, notice that the y values don't change. They're all the same. All right, so you may be able to draw on your knowledge back from the previous lesson. Let's go ahead and apply the formula once again here. All right, so I have x1. I'm going to use y1 first, is 2 minus y2, which is 2, over x1, which is -1, minus x2, which is 1. So I get 0 over -2. So 0 divided by anything besides 0 is 0. So that's the slope of the line based on table B. All right, part C now. Notice that none of the x values change. All right, so you should know how to graph something like this, and based on the graph, you should be able to tell what the slope is, but let's do it mathematically. So we have x1, y1, x2, y2. All right, plug in our values in. y1 is -3. Minus y2 is 0, and then I have x1, which is -3, minus x2, which is -3. So I end up with -3 over 0. All right, whenever 0 is under, your answer then is undefined. There is no number. All right, you cannot divide by 0. The slope is undefined. All right, moving on to the next example. Okay, identify the slopes and y-intercepts. Okay, to identify the slope of y-intercept, you want to convert each equation into slope-intercept form. Y equals mx plus b. This is slope-intercept form. All right, once it's in this form, it's very easy to identify the slope, which is m, and the y-intercept, which is b. Okay, so now I have y is equal to 3x minus 4. That's in the structure I want. So what is my slope? What is my m? All right, that's going to be 3. And what's my y-intercept, my b? That's 4. All right, so that's my slope. And that's my y-intercept. Just want to make sure that's clear. All right, y is equal to 6.5. All right, what is my slope here? What is my y-intercept? Well, I have y isolated already. So what's going on with this? What happened to the x? What would you have to multiply x by for it to disappear? 0. Okay, I did that so I would obtain this structure here. All right, and this tells me then that my slope is 0. That's my slope once again. And my y-intercept then, which is b, is 6.5. All right, that's all there is to that. All right, next one, there's a little more work involved. I have to do a bit of algebra. This goes back to the first chapter. All right, we have to isolate the y. Don't forget the negative here. Watch out for that negative. I always get students. All right, next thing is I have to get rid of that negative 1 there. There's always a 1 there. All right, so the negative's gone now. Divide the negative into both parts. So I have negative 5x plus 2. All right, now I have it in slope-intercept form. I can easily identify the slope, which is negative 5, and the y-intercept, which is 2. All right, on to the next example. Hang in there, we're almost done. Using slope-intercept form to graph. Okay, identify the x-intercept. Okay, so first thing, let's get our equation in slope-intercept form. So I'm going to subtract 2x here. Get y equals negative 2x plus 2. All right, now it's the slope-intercept form. So I have m is negative 2. That's my slope. And my y-intercept is 2 as well. So b is equal to 2. All right, now let's throw up a grid to graph on. All right, there we go. Okay, so how does this work? My y-intercept, my y-intercept is 2. Okay, so that means I go on the y-axis, always on the y-axis for the y-intercept. I go up 2. From the origin, I go up 2. All right, so that's my y-intercept. Very important point. Now the next piece of information, my slope, negative 2. Now whenever you're graphing, you want to make sure your slope is written as a fraction. So how do I do that? I simply put it over 1 in this case. Okay, now I'm applying my slope. Slope is rise over run. Okay, rise means you're going up or you're going down. Since it's negative 2, that means I'm going down. And then for my run is 1. That means I'm going to the right 1. If it was negative, I'll go to the left 1. Okay, so I'm going to go down 2 and right 1. Down 2, right 1. I think my pen just ran out of power, or it's going to. Okay. So I go down 2 over 1, down 2 over 1. And I could go back to the y-intercept, and I could go up to back 1, up to back 1, up to back 1. And I just realized that the pen I was using is making a lot of noise while I lecture. So now I got this other pen that doesn't make any tapping noise. I think you'll enjoy the lectures much more now. Okay, so I have all my points on the grid now. Oh, let's get one more. Down 2 over 1. All right, so I could graph my line. There we go. See, no noise, nice and smooth. All right, then the last piece of information, identify the x-intercept. Just by looking at the graph now, I can identify the x-intercept. Where does the graph cross the x-axis? Right there. And what is that value? That x-intercept is at the point 1, 0. Or you could also say x is equal to 1. All right. Going on to the last example. Okay, starting example 5. Now there's no more tapping, there's no more of this. All right, if someone would have told me earlier all the tapping noises on my lectures, I would have changed it much sooner if someone had spoken up. Okay, but now I have this pen that makes no noise, so the lectures should be much easier to listen to. All right, if there's ever issue with anything in the future, guys, please let me know. All right, I'm here to make the lessons as enjoyable as possible, so just speak up. All right, so a linear function G models a relationship in which the dependent variable increases 3 units. For every 1 unit, the independent variable increases. All right, what does that mean exactly? All right, well, x is your independent variable, and y is your dependent variable, because y is always determined by whatever x is when you plug it in. All right, then it says here, graph g when g of 0 equals 3. All right, well, g is no different than f. All right, we could use any letter for a function. All right, and this value here, this 0, represents my x, and whatever I get outside here, that represents my y. All right, so that's 1 point, 0, 3. All right, so it says graph this function. All right, it's telling me that g of 0 is 3. All right, so they just gave me the y-intercept, essentially. Then this information up here, this tells me what my slope is. All right, it says when the dependent variable increases by 3 units, for every 1 unit, the independent variable increases. So they're telling me what my rise over my run is. Okay, because the rise is the change in the y, which is 3 units, and the run is the change in the x, which is 1 unit. So my slope for this equation is 3 over 1. So that answers the first question here. The y-intercept, well, I already have that based on the information they gave me here. That's 0, 3. All right, I have that. And then the x-intercept. Okay, well, to find the x-intercept, I need to graph the line. Let's use our slope. Starting from the y-intercept, up 3 and over 1. All right, then go back to the y-intercept. And I'm going to go backwards now. I'm going to go down 3, back 1. Down 3, back 1. Down 3, back 1. Now I could graph my line. And based on what we have here, we can easily identify the x-intercept right here. And what are its coordinates? All right, well, to figure out the point, you first go along the x-axis, or you go along the x, and then you go along the y. So I go to the left 1, and then up or down 0. I don't move at all. Going vertically. All right, there's my x-intercept. I have all the information I need. So there's a lot going on in this problem, but if anything didn't make sense to you, please make sure to ask for help. We're done with the chapter. Begin the assignment at the bottom of the webpage.